Welcome back, everybody. Everyone had a good weekend. There was a small typo on one of the on one of the review problems. We'll talk about that when we get there. But we were working on solving trigonometric equations using Pythagorean identities. So, where were we? Where were we? What page is that? There it is. There it is. Okay. I don't need it, but regardless. So cosine of 2x minus cosine of x minus 1. So much like with an equation, cosine of 2x and cosine of x, they're like two different variables. So as it currently stands, there's no way to solve it because you have two different variables. It's like trying to solve y minus x equals -1. There are certainly ways to find places where like the solutions to it, but at the end of the day, it's not going to work unless we find a way to relate y to x. So, in particular, we can use a Pythagorean identity. So, John Doe's student, silly John Doe, he's like, oh, I got this. I know one of the Pythagorean identities for the double angle formula. I know the double angle formula. Cosine of 2x is cosine squared of x minus sine squared of x. And so then it's minus cosine x minus equals -1. Why is that not good? It gets us closer, definitely. Because now we don't have a 2x. We don't have a different variable involved. But now we have a sine, we have a cosine and a sine. And that makes it very difficult to find a factorization. So that's not the right formulation. The good news is that sine, or cosine of 2x, has 3 different formulations. Which one should we use? Number 1, number 2, or number 3? Number 3, because that one purely deals with cosines. So we're going to convert the cosine 2x into a 2 cosine squared of x minus 1 minus cosine of x equals -1. I'm going to put the cosine, the 2x, what I converted it to, into parentheses. Is it necessary here? No, it's not. However, what if it was this instead? Negative cosine of x minus, or let's see. What if it had been cosine of x minus cosine of 2x equals 1? In that case, the parentheses would be absolutely necessary because that minus sign would need to get distributed. So please don't forget to distribute minus signs, distribute constants wherever needed, okay? It's a very classic mistake that students make. I don't need to have the parentheses there, but much like helping a dying bee on the street, it's not going to hurt, right? Right? You're not necessarily going to get good luck from helping out a bee, but or not stepping on a crack, but it couldn't hurt, right? So in the same vein of things, like I don't necessarily think that praying actually does anything per se, but it couldn't hurt, right? It couldn't hurt. Or believing in karma. Karma doesn't necessarily, there's no way to prove that karma exists, but I like to think that it does, and it helps me live a better life. So point being is parentheses. Please use them. I'm getting sidetracked. Anyways, let's simplify. Just like any polynomial equation, we would do this. We would get everything to one side. We get 2 cosine squared of x minus cosine of x. And then we've got a -1, but then we're going to add 1 to both sides, so it's going to cancel out. We get this. And that thing factors nicely. There's a common factor, cosine of x. So we can factor that out front. Cosine of x times 2 cosine of x minus 1 is equal to 0. So that gives us either cosine of x equals 0 or cosine of x equals 1/2. So cosine of x equals 0 from a unit circle approach. That would be when that's the x coordinate. So that would be at pi over 2 and 3 pi over 2. And then from the second one, 1/2. So you can either think of it as the x coordinate of the unit circle, or you can think of it as the side length, the horizontal side length of any triangle. 1/2 is the small side length. So we need the big angle triangle. We need the one that makes the like this one right here, make the 30-degree makes the horizontal be the big side. But we want the small side. So we want pi over 3. But there's also another one because cosine is positive in the first and fourth quadrants. There's also 5 pi over 3. The thing I love about general solutions is that you could also, if you didn't want to try and figure out what 5 pi over 3, you could just write negative pi over 3 and it'll be good. But oh well. And yes, Alex will want you to have them in ascending order, but I don't care. I simply do not care. That is not useful information at the moment. But I mean, you could organize them if you really wanted to. And if you're having trouble figuring out how to organize them out, one second, then like if you're having trouble figuring out how to organize them, just ignore the pies and look at the fractions. 1/2, 3/2, 1/3, and 5/3. So 1/3 is the smallest fraction. 1/2 is the next smallest fraction. 5/3 is the next smallest fraction, and 3/2 is the biggest one. Alex.
As for the test, to bring our answers down, we can leave it as 2x if they're demonstrating both sides of the equation.
Yeah, you can write the x equals. You don't have to write it as a full set. No need to do that unless, I mean, I'm doing it so that we see exactly where the zeros come from. But usually in practice, if I'm doing this myself, I just write it in a whole list. I just work with this one, write down the answers, then work with this one, write down the next answers. But I'm not going to be too heartbroken if you do that. Okay, any questions? The next thing that can come up is what if the inside is not just x? Because we've dealt with plenty of trig functions that have variables on the inside. They have, or they have constants on the inside. Sine of 3x. That thing increases the amplitude, right? The higher the number, the more of the amplitude becomes larger. Sorry, not the amplitude, the period, excuse me. The higher the number, the more it repeats itself, the faster it does. And so the thing is, the good news is it gets solved just like normal. So we try and solve the thing. Just ignore this for a second and call it theta, right? You can do a substitution. And so then you either get that 3x is equal to 5. So solving this equation right here, subtract square root 3, divide by 2, you get sine of 3x is equal to negative square root 3 over 2. So that would mean that the inside is either going to equal 4 pi over 3 plus 2 pi k, or 5 pi over 3 plus 2 pi k, because those are the two places where sine will equal negative square root 3 over 2. And then what you're going to do is you're going to solve each of those equations for x simply by dividing. So you divide both sides by 3, and that gives you, and so remember, if you're dividing both sides by 3, you're going to divide each term on the right-hand side by 3. So 4 pi divided by 3, that's 4 pi over 9. 2 pi over 2 pi k divided by 3 is 2 pi k over 3. Now, I've written it this way so that we can add it easy. If it was asking for just a general solution, I would just stop right here. If it's asking for a general solution, I'll just stop right here because that's the simplified form. But this is asking for answers between 0 and 2 pi. So it would be nice to write them to have the same denominator. That way, we can add them quickly. Any questions on that so far? So it's the same process that we've been doing, literally the same thing. It's just instead of solving for x, now we have 3x or 5x or negative 2x or something like that. Doesn't really matter. And so what you see that I've done here is I've started plugging in k values to see when I get solutions. You'll notice that I didn't put in negative 1. And that's because 2 pi over 3 is going to be larger than 4 pi over 9. So if I put in k equals negative 1, this thing is going to be negative. So it's going to put me outside of the interval already. So that would be, wait. Yes. It'll put me outside the interval. So I don't even bother testing it, but that's not to say I couldn't. You could test k equals negative 1. You'll get you'll get negative 2 pi over 9 and negative pi over 9. So you'll see that they're not there. Jake, yes.
If the numbers weren't obvious, you pretty much have to go like -1, -2, +1, +2, just to make sure you cover.
That's what I would do, yes.
Okay.
Yes. If it was me, I would check. I like personally, I like to check. I like to be triple sure. So I'd plug in k equals -1 and I'd see that I get negative answers. So I don't need to check k equals -2 because that'll just make it more negative. And so once you found some negative answers, then you can stop because it'll only give more negative from there on. And so we start testing them. We get 4/9. That's in between 0 and 2 pi. So I'm gonna put a check mark. This one's in between 0 and 2 pi. This one's in between 0 and 2 pi. This one's in between 0 and 2 pi. K equals 2. That's in between 0 and 2 pi because it has to be 18 pi over 9 to be 2 pi. So maybe write this note up here. 2 pi is equal to 18 pi over 9. So as soon as we get above 18 pi over 9, we're not in it. 17 pi over 9, that's in it, but these ones are not because they're bigger than 2 pi, which equals 18 pi over 9. They're bigger than 2 pi. So we have 6 solutions this time. Question?
How would you would just write as x is equal to all of those?
Yeah.
Preferably in order.
Preferably in order, but it's not the end of the world if you don't. The good news here is that all of them have the same denominator, so it is very, very sequential. But if you get weird answers, if you don't get pi's over 3, so if you get a pi over 3 and a pi over 4, then it's annoying. And that's the reason why I don't really care about you organizing them. Alex does, but I don't want you to waste that precious time on the exam for focusing on that. So I'd like us to do this one. Let's kind of talk our way through it. What should we do first? Isolate the cosine. That's right. So we'll add square root 2 and then divide by 2. So we get that cosine of the quantity 2x over 3 is equal to square root 2 over 2. If it helps you, by the way, this is not necessary, but if you're getting like if the 2x over 3 is creeping you out, just cover it up with a theta and solve that, and then substitute back in once you're done. But square root 2 over 2, that is going to be the 45-degree angle. Cosine is positive in the first and the fourth quadrant. So we have the pi over 4, and we have the 7 pi over 4. So 2x over 3 is equal to pi over 4 plus 2 pi k. And 2x over 3 is equal to 7 pi over 4 plus 2 pi k. For k and z, but we'll write that at the end. Honestly, as long as you write it one place, I don't care if you forget about writing in the final answer. Like that's such a niche thing. That's a mark down because I'm angry, not because I'm being a legit teacher. So anyways, we'll solve for x. So you can either do it in 2 steps or you can multiply by the reciprocal, which is what I'm going to do. I'm going to multiply by 3 over 2. And that gives me just x is equal to 3 pi over 8 plus 3 pi k. And then x equals, let's see here, 21 pi over 8 plus 3 pi k. Say what? Yep, that should be rejected. That should not work at all because that's already bigger than 2 pi. Yes.
Except for isn't
K
3 pi. What's that?
Go ahead.
Didn't that be a 3/8 pi?
Uh,
Missing something.
the 3 pi k. Am I screwing up something?
No, maybe I was. Oh no, I got it now. Okay,
We're good?
sorry, I didn't catch up. Yeah.
That's all right. Hey, I bite my tongue just like everyone else, right? We all make mistakes. I've been eating for for over 30 years, and I still make that mistake. Yes, Amaya. Say that one more time.
Where did you get that third line from? That you're multiplying by 3?
So, excellent question. So I'm multiplying, so I have to distribute this in, right? 3, where am I getting 3 over 2? I'm getting pi over 4 plus 2 pi k because that solves this thing. Is that right? And then same thing for 7 pi over 4. So we'll plug in some k values. I think it would help, it would behoove us to maybe test k equals -1, but it's not necessary. But like it ends up not being necessary, but I'm still going to do it. K equals -1. First and foremost, if I was just asking for the general solution, I'd leave it like that. But I'm going to rewrite this as 24 pi over 8k. Because I want to rewrite it with the same denominator to make sure that it's easy to add. Now, granted, your calculator can handle this for you, so don't worry too much if you don't want to do that. But I think it's a cool trick to be able to do. K equals -1. I'm going to show the algebra right now, but after this, I'd like us to skip the algebra and write down the numbers. So k equals 1, we get 3 pi over 8 minus 24 pi over 8, which equals -21 pi over 8. That's not good. That's not between 0 and 2 pi. Similarly, we'll plug in the other one. 21 pi over 8 minus 24 pi over 8. And it's minus because I'm plugging in k equals -1. It's plus 3 pi k, so it's going to be plus 3 times 3 pi times -1, which will just make it subtraction. And that'll be -3 pi over 8. And that's also not in there. Then we'll test k equals 0. So that's what I'm doing in my head or in my calculator. I want you to be able to do that in your head. You don't have to. You don't have to. But if you can, that's perfect. This will be 3 pi over 8. That one is in 0 to 2 pi. And then 21 pi over 8, that is not in 2 pi. Because bigger than 2 pi, which equals 16 pi over 8. We got 3 pi k's, but that's not what we want. Yeah. Any questions on that? Yes.
So this is something I had to look. So if your k equals 0 is no good, you're not done. You still need to check after subtracting the period.
Yeah.
Or adding a period, it might bring you back into the 0 to 2 pi.
So, excellent question. I'm not even going to bother, so this brings up Jake's point. So your first value is already not in 0 to 2 pi. And any more that I increase it is just going to keep adding more pies. It's going to keep adding more. So I'm effectively done checking the second solution.
Negative. What about going?
So that's what so that's why I do check the -1. So that's my preference. I like to check -1. I like to start with -1. And I mean, most of the time we end up having the numbers already between 0 and 2 pi. So like adding it, like subtracting a 2 pi is going to put you out of the interval right from the get-go. But you never know. Like every situation is different.
Is k0 always positive?
K equals 0 will probably always give you a positive number. Yes.
Okay, that's why going there, if it's already out, then you don't have to worry about going, doing any positive checks. But you have to do at least one. Potentially, it might take a -2 to get you back into the circle, right?
It might. Very rare, but it could. So it's always like that's why I always check at least one -1. Like I at least check k equals -1 because it could bring me inside 2 pi if my number gets so large.
Right, and if it just gets you like closer, you might have to check one more to see if it brings you in.
Yes, that's correct. And then we'll do k equals 1. I don't even need to bother though. I'm going to do it regardless because I don't expect you to be clever on an exam. That's not like exams are not a time to be clever. Exams are a time to just try and get the problems out, trying to make sure you're mastering your processes. But the reason why I know I don't need to even bother checking k equals 1 is because I'm going to be like, if I put in a k equals 1, that's going to add 3 pi. And so that's already going to put me out. No matter what my number is, as long as it's positive, if I add 3 pi k, if I add 3 pi, it's going to always put it outside of it. But either way, you'll get 27 pi over 8 because it's going to be 24 plus 3 pi over 8. And that's going to be 27 pi. That's not going to be there. And then we already knew it, but let's still do it again. That'll give me 45 pi over 8. That's also not out. So there was only one solution. X equals 3 pi over 8. That was our only solution. I made a typo in my notes. Any questions on that? Yes, Brian.
You multiply by 3 over 2 to get x by itself, right?
Yes.
So I don't get how it goes, how 2 pi k when multiplied by 3 over 2 is 3 pi.
Excellent question. So we can do that off on the side here. And this is why you always have scratch paper with you. I always have the last page of my exams have scratch paper. So 3/2 times 2 pi k, that's technically over 1. So the 2's cancel. And then it's just 3 times pi k, so it's 3 pi k. Is that all right? It's okay. Once again, remember, I didn't realize why it was called a triangle until I was 21 years old. So, come on.
At the end of the day, the 21 pi over 8 is not a solution because it's bigger than 2 pi anyway.
That's correct. Because it's larger than 2 pi, which is 16 pi over 8, it's already outside of the realm. And that makes sense if you think about it from a graphical standpoint. 2 pi over 3, that's a number smaller than 1, right? So that means that the period is going to get expanded. So in order for it to complete a full period, normally we get 2 solutions because the function completes itself in 2 pi. And so it will have 2 places where at least 2 places where it gets that answer. But because this thing has been stretched horizontally, it will only actually end up having 1 solution in that interval. Cool? Eli, do you have a question?
So I know like that. That's already 3 pi over 8. Do I need like write all the k values down?
No. If you this is the other thing. I'd like to see it just so that I can make sure I give you full credit. But if you just want to test them in your head, and then just write down the answers, you can do that. You can write down the solutions. Like I'd like to see, like, even if you just want to write k equals -1, k equals 0, just so that I know that you tested them, that would really help me, just so that if you make a mistake, I can give you credit. Because if you don't show that work and you get the wrong answers, then there's no way for me to give you partial credit. And I hate not being able to give partial credit. It's my favorite part about grading. Test is Wednesday, that's correct. Last one, and then we get to move on to calculator stuff, and then we get to go on to the review. So cosecant of 5x plus 4 is equal to 5. Solve it like normal. Isolate the cosecant. So cosecant of 5x is equal to 1. And unless you're super cool and you have your cosines memorized, or your cosecants memorized, I'm going to convert this into a sine. I'm going to take it as a sine to convert it to a sine. And so that's what I'm going to do. So that is, oh, there was a type. typo. No, that's fine. Yeah, it's just one. So sine of 5x. I think this was supposed to be a 6. I think I made a typo. Well, we'll just do this. We'll just do this. This will be fine. This will be 1 over 1, which is just 1. So that means that 5x. So when does sine equal 1? It equals 1 at one spot. Pi over 2. So we have 5x is equal to pi over 2 plus 2 pi k. But we don't want 5x, we want x to equal. So we get x is equal to pi over 10 plus 2/5, 2 pi over 5k, which for the easiness to plug in k values, I'm going to write this as 4 pi over 10k. I'm going to multiply by 2 over 2 to get it to be the same denominator. So I don't need to test k equals -1. I don't, but I can. I'm going to do it just because it's useful to check, just be certain. But you guys see why I don't need to bother. The reason I don't need to bother is that 2 pi over 5 is already bigger than pi over 10. It's a smaller denominator and a bigger numerator. It's going to be a larger number. So if I plug in -1, it's already going to push me outside of 0 to 2 pi. It's going to give me a negative answer. But you can verify that for yourself. And so we'll do it just because it's worthwhile. K equals -1. We get x is equal to -3 pi over 10. And that's outside of our interval. K equals 0. X equals pi over 10. That's going to be in my interval. K equals 1. That'll give me x equals 5 pi. That'll give me pi over 2. K equals 2. That's in there. K equals 2 will give me pi over 10 plus 8 pi. So that's 9 pi over 10. I should have been nicer on K equals 1. I'll write this as 5 pi over 10, which equals pi over 2. And that's in there. That's in there. K equals 3. That'll give me x equals 14 pi. 14 pi over 10. And that is in the interval. When am I outside of my interval? Don't say it out loud. Get a chance to it. So when do I need to, what value of blank over 10 do I need to be looking out for? 20 pi over 10, because that's 2 pi. So you can even write that off on the side, 0 to 2 pi. This is 20 pi over 10. How do we get 14 pi over 10? So 3 times 4 pi over 10. 4 pi over 10 times 3 gives me 12 pi over 10. And so adding 2 more pi. Oh, 13 pi. 13 pi. I'm 13 pi. Thank you. Thank you for catching that. And that is in the interval. And I think we'll get one more, and that'll be it. X equals 17 pi over 10. I could do it by hand. I think someone's noticed. Were you saying 17 pi? Yeah, I think you were figuring out all you need to do is just keep adding 4 pi over 10. Yes, that's another trick. So Lamar was noticing something. It's always going to be adding 4 pi. The denominator is going to stay the same. So add 4, you get 5 pi. Add 4, you get 9. Add 4, you get 13. Add 4 again, you get 17. And that one is also in there because that's less than 20 pi over 10. And last but not least, you get k equals 5, and you'll get x equals 21 pi over 10, and that's going to be bigger than 2 pi. Now, as a fun observation, you can tell yourself that you know that it's done because the denominator is 2 pi over 5. So once I multiply by a 5, I'm adding a 2 pi, which will immediately put me out of 2 pi. That'll immediately make me larger than 2 pi. So that's where I can stop. But so if you notice that and you want to skip right at checking k equals 5, be my guest. So you get the answer should be x equals pi over 10, pi over 2, 9 pi over 10, 13 pi over 10, and 17 pi over 10. And this makes sense why we have so many solutions, because we have shrank the graph horizontally. By making the period 2 pi over 5, it repeats itself every 2 pi over 5. So in 0 to 2 pi, we have 5 of them. 5 repeats. Any questions on Brian? Yes.
So you turn the cosecant into a sine because they're related, right?
Yes, that's correct.
And the reason why you did 1/1 is because cosecant is 1/sine.
So excellent point. So I'm going to highlight this. So this is one. This one here is this one. Because sine, cosecant is 1/sine, and by consequence, sine is 1/cosecant. All right. Any other questions?
Could you go over again, what was the logic you used to determine, that negative, that k equals -1, you didn't even have to bother with it? I see how it works, but like, what was the logic you said?
So my logic for why I wouldn't bother with k equals -1 is that this number, 2 pi over 5, is bigger than pi over 10. So if I make it a negative, I'm subtracting a bigger number from pi over 10, and that'll immediately make it negative. Thank you guys for asking these questions. Like, always when you throw in the pi with the fractions, it starts to throw things off in our head. It doesn't feel right at first. And so it just takes practice, though. Other ones. Last concept. What if you don't get a nice number, which is far more often in the real world, honestly. This is the more applicable situation because it's very rare that you get perfectly 45-degree angles or something like that. I mean, there is something to be said about civil engineering and like trying to make sure you get those perfectly, like those really nice angles. They are important, right? I mean, I'm not a civil engineer. I don't know. I can't make a bridge, but I know that there is something with the angles that are perfect to make that cool X mark that's very, very nice. And that anything less than that makes it less sturdy or whatever. I'm not a civil engineer, so I can't speak to that front. What I can tell you is it's very rare in the real world that you get exactly a pi over 4 or a pi over 6. So how do we solve this problem right here? Cosecant of theta is equal to 100/53. That's not going to give me a nice angle. So first and foremost, we always rewrite things in terms of sines and cosines because those are easier to work with. And then you're going to use inverse trig to find your reference angle. Because remember, inverse trig has restrictions. Sine inverse only produces angles between -pi/2 and pi/2. Cosine inverse only produces angles between 0 and pi. And tangent inverse also from -pi/2 to pi/2. So when you get this, it will give you your reference angle. It might be an angle, it might be a solution, but and it also depends on what interval you're working on. So we use it, and that gives me approximately sine inverse of 53/100. That's roughly 0.53, which is pretty amazing if you think about it. That sine inverse of 53/100 is equal to 0.53, which is 100 is 53 divided by 100 is 0.53. So it's pretty miraculous that happens. Sorry, I want to change this to radians. Sine inverse of 53/100, 0.53. Yeah, 0.55. Oh, no, it's not 0.55. I got too excited. This is well, actually, I'd love to show you guys something real quick. It would be, but it might be a waste of time. There's a thing called tangent polynomials or Taylor polynomials, and Taylor polynomials allow you to approximate functions with polynomials instead of just with the actual sign. And it turns out that the first Taylor polynomial is just y equals x. So it's actually pretty accurate. 0.53, 0.55, they're roughly the same. They're very, very close to each other. If we have a chance, I'll show you something. That should be 0.55. Sorry, that's a typo. So sine inverse of 53 over 100 is 0.55. And that number is between 0, and it's in radians right now. And that's between 0 and 2 pi, 0 and pi over 2. So that will be one of the answers. But because sine is positive in the first and the fourth quadrant, we need to find the other solution. And how do we do it? How do we do it? Oh, getting that away. I mean, you can see it because it's on your page, but now we're looking at this. Theta sub 1 is just equal to theta reference. But theta 2 has this angle, which is the theta reference. This angle right here, this is theta sub reference. So to find theta sub 2, I have a full I have a full pi, and I want to take off that theta reference. So I do pi minus that theta reference, which gives me what the theta values are, 0.56, 0.55, whatever you want to do. I don't care. And then approximately 2.58. Let's do it again. Let's do another example. Let's do at least two. I don't really, I'm good without this. I'm good without, is that the only, let's skip those. That's unnecessary stuff. Really, like it's trying to help you. We're trying to help you with the reasoning, but I don't need to do this. It's rather better to do these examples. Cosine of theta is equal to negative 5 pi over 6 on the interval 0 to 2 pi. So that is not a nice number, but it's already got cosine isolated by itself. So that means that theta is equal to cosine inverse of negative 5 pi over negative 5 over 6. And I'll use my calculator. Cosine inverse of negative 5 over 6 is 2.555. So approximately 2.56 radians. So that is a number between 0 and 2 pi. Zero and 2 pi. Oh, whoa, sorry. And the reason why I know that is 2 pi is roughly, I'm going to put this up here as a comment. 2 pi is roughly 6.28. Yeah, 6.28, approximately 6.28. So as long as I'm less than 6.28, I've got a radian that's in the measurement that we need. So the thing is, though, cosine and all those things, they have multiple solutions. So we have to start looking at it. And so, yes, you can try and memorize what were on the other pages, but I don't agree with that anymore. What I'd rather you do is draw a number line to visualize it. So 2.5 radians. I'm going to call that, I'm going to underline that in red. That's right around here. It does not need to be perfect. We'll call it theta sub 1. We also have to have this one right here that has the same reference angle. We'll call this theta sub reference. And that's also theta sub reference. It's getting a little bit busy, but this right here, that is theta sub 2. There's the colors are not right. I chose bad colors. Let's change this to green. That's theta sub 2. Is that okay? Any questions on that? Do we all see how that's going to be the other solution? It's okay, Eli. Yes. Say what?
How do you do it both? I didn't get it.
Okay, so theta sub 1 is in quadrant 2 because pi over 2 is like 90 degrees, is approximately 1.57. Right. So we're in quadrant 2. That's how we found the first theta, because inverse trig can only produce one solution. We have to create the second one. We have to find it. And so we know that cosine is negative in the second and third quadrants. And in order for them to have the same cosine value, they have to have the same reference angle. So this angle here and this angle here give me the same value. So theta sub 2 goes all the way down here. Is that okay so far? So now the question arises, how do I find theta sub 2? So take a second, figure it out for yourself. This is an important mental trick. I don't want you to memorize a million formulas. How would we find theta sub 2? Like, if we knew what theta sub reference was, what would theta sub 2 be? It'd be pi plus theta sub reference. Because this, from here to here, that's a full pi plus an additional theta sub reference. But the thing is, we don't know what theta sub reference is. Alex.
Theta subtract from, pi subtract from theta 1.
Yes, exactly right. So theta sub reference will equal pi minus theta sub 1, which is equal to approximately, so pi minus 2.56 is 0.58. So theta sub 2 is pi plus 0.58, which is approximately 3.72. And that is also between 0 and 2 pi. So let's before we go any further than this, let's make sure we're all on the same page. So once again, cosine inverse, when we do that, we get one solution because cosine, like all the trig inverse, they can only produce one answer. But trigonometry is very, very nice and symmetric, so there's multiple answers. In particular, we know there's going to be a second solution in the third quadrant because that's another place where cosine is negative. And as long as we make the same reference angle, the cosine will produce the same number. So we need to first off find theta sub 2. It's going to be a whole pi plus that theta sub reference, but we don't know what that is because cosine gave us the full angle. Sometimes sine and tangent are usually nicer in this aspect, but regardless. But we can find theta sub reference because we know this is a full pi, and we know that therefore that theta sub reference is going to be a full pi minus theta sub 1. That's where we got 0.58. So to find the second theta, the green angle, we have to do a full pi plus an additional theta reference, and that gives us 3.72. So the general solution is theta equals 0.58 plus 2 pi k and 3.72 plus 2 pi k. I'm only doing this because what if this was a problem where you had to find, what if it wasn't theta, cosine of theta? What if it was cosine of 2 theta? Or cosine of 1/2 theta? How will we find it then? We need to be able to use the general solutions. And I know that looks weird, but it's nothing different than what we've already done. We're trying to find the angle. This time we just need to use inverse trig to find the angle. And it's always the angle plus 2 pi k for k and z. But in particular, we're only working with 0 to 2 pi, so our actual answer, which should have gone above it though, but either way, 0.58 and 3.72. That is a mouthful. That is trying to eat grape nuts by hand, not even bothering letting it sit in milk for 40 hours, you know. Has anybody had grape nuts? Does anybody know what I'm talking about? Who knows what grape nuts are? The older people in the crowd, slightly older. Grape nuts is a very, very high fiber cereal. Basically, but like very, very tiny piece. It's try it sometime. You'll add a little bit of sugar. It tastes like awful without anything in it. Add a little bit of sweetener or something. Otherwise, it's bad. But anyways, I'm getting sidetracked. Someone had a question. Okay.
Just on labeling, if it's radians, you don't have to label, right?
That's correct. That's so Jake asked an excellent question. If you're going to write your answers in degrees, you need to use the degree symbol. That's the convention we have decided upon in mathematics, is that if it doesn't have a degree symbol, it means it's in radians. All right. Let's do another one together, and then we'll move on to the review. And if we still want to do another one of these, there is one on the review. So cotangent of theta is equal to negative 1.12. Now, I don't know, there's no cotangent inverse button, so we have to convert this to tangent. Tangent of theta is equal to 1 over negative 1.12, because tangent and cotangent are related that way. They're reciprocals of each other. And so that means that theta is equal to tangent inverse. I'm not gonna write down an approximation yet. I'm going to go, I mean, on the exam, you can approximate it, and I know what you're doing. But on Alex, you probably want to write this as 1 over negative 1.12, which is approximately tangent inverse of 1 divided by 1.12. And let's put a negative sign, otherwise I forgot it. And I get theta is equal to negative 0.73. So this is not a solution. Not a solution in 0 to 2 pi. But it is the reference. It will give us the reference. That's not going to work. So it's not really a solution. So let's draw a sign, let's draw a unit circle to help us figure this out. 0.73 radians, negative 0.73 radians, that should be in quadrant 4. And we're just making an approximation. It's going to be roughly around here. That's going to be 0.73 radians. I guess technically negative, but it's going to be the so let's say theta sub reference, which equals 0.73. The angle itself is negative 7.3, but the reference angle is always a positive number, 0.73. So, yes, Brian. So the inverse functions, they will either produce an angle between 0 and 2 pi, like specifically, I guess, are you wondering how I know that, like, because the answer is negative 0.73, that the reference of that would be 0.73?
Yeah, I don't know where.
Sure. Yeah, I realized I jumped a few steps. So measuring this angle, which I'm gonna underline in, let's do pink. So that would be, and let's make sure, like, this is not how far it goes down. It's much less than that, but because I want to maybe be able to see it. This is, let's call this theta underline. So when I've got that arrow there, that's negative 0.73. But if I'm just measuring the the angle of this triangle that gets formed, if I'm looking at this angle, that's a positive. If I'm looking at it like in terms of a triangle, it's a positive angle. So, but it's the same thing, so just without the minus sign. So that implies that theta sub reference is 0.73. Is that okay? So we need to find the actual solutions. So one of them will be in which quadrant? Which one do you want to find first?
2.
Quadrant 2. That's going to be one of them. That's going to be over here. So we'll call that theta sub 1. How do I find theta sub 1? Oh, wait, like, I'm gonna wait, let everyone get a chance to think about it, though. This is something you're gonna have to be able to recreate on the exam, right? Might need to. How do I find it? So Jake had the answer.
Well, I was just gonna add pi to the original, angle.
Excellent point. Excellent point. That's actually a very, very good point. That would be a much cleverer way to do it. So what Jake is planning to do is just adding pi to this, and that'll immediately put me here. And then you could add another pi to get the answer between 0 and 2 pi. That is correct. That is the best way to do it. But I wanted to but I don't want to be like, you're not, I don't like you being more clever than me. How dare you? No, that would be the clever way to do it. That would be the clever way. If you want a more generalized approach, if you have it there, actually, that's just smarter. That's just a way better way to do it. It's just a way better way to do it. Okay, so you could add pi, or you could think of it as this is theta sub reference. So we could either add pi, or we could do theta sub 1 is equal to pi minus theta sub reference. Either way, you'll get the same answer, which will be, so shift pi minus 0.73, and you get 2.41. That's the first answer. And the second answer, which I'm going to do in blue, is going to be going all the way around to there. So really, as Jake mentioned, you could do this the clever way and just say that, okay, all I need to do is find a coterminal angle. So all I need to do is just add 2 pi to my angle to get to it. Or you could think of it as doing 2 pi minus theta reference. However you want to do it, that's theta sub 2. Theta sub 2 is going to equal 2 pi minus theta sub reference, which will equal 5.55. And those are my answers. Those are two answers between 0 and 2 pi. If we wanted to find the general solution, since this is tangent, it's pi periodic. So you really only need to do the 2.41 situation. But either way. Any questions on that? It's okay if this is like, please ask any questions that you have. Right? With the remaining 30 minutes or so, we can do review. Because that's the end of those notes. So I've got the review. Hopefully you're able to look at it. So we mentioned it at the beginning, but there was a small typo on this problem. It was supposed to be U plus 8 from the get-go. And I think the answer key was correct, but if not, like the solution guide also was incorrect. I'll resend it out later today with the corrections. Did you guys like this problem? You thought this problem was cool? Because I thought this one was awesome. Did you guys note if you zoomed in, you saw the irregular flight pattern and the fact that the wasp had a sword and the dragonfly had a gun?
Not an equal battle.
Well, yeah, because dragonflies are like the apex predators of the bug world. In case you did not know, dragonflies are like really good at killing. They are incredibly good at getting their prey. Well, beetles are cool, yes, but like a dragonfly, you don't mess with dragonflies. If I was a flying bug, I would be threatened. I would be very, very scared of a dragonfly. But either way, he brought a gun to a knife fight. Anyways, so any of these questions you guys would like to do? I think all these things are fair game. Remember that a review is not meant to be a full guide of everything. This is just some problems that I think are a good estimate. If you can do all these, you probably should be good. But always make like this shouldn't be your only form of study, is what I'm trying to say. There are other things that could show like that are useful to study. All right, does anybody want to do any of these ones in particular? I can scroll through it, and if you want to choose one. Jake, do you have a question?
Cover, what I was mentioning before.
6C. While he's looking for his one, you guys can definitely ask any questions. 9E. 9E. Okay. Let me go ahead and copy that and we'll work through it together. Okay. Page. Nine. All right, we're trying to prove that identity. And unlike Alex, I am okay with you starting with either side. So, and remember, you will have all of the formulas save for the Pythagorean identities, which you will deduce. That'll be one question on the exam, to deduce all other 8 besides sine squared plus cosine squared equals 1, because you are required to know that. Yes, Basil.
Yes, just make sure, like, you said that, like, we could modify both sides.
Yes. You can start with either side to prove it. Yes, I am fine with that. Alex, I know they're very, very particular about starting with the left-hand side. If you see the right-hand side as better to start off with, be my guest. I see the minus sign being multiplied together. So I'm going to go ahead and work with the left-hand side personally. So let's start with tangent of theta. It's been a while since I did the solution, so I don't remember how to do this one. So I'm going in blind, and I think that's the best call. Tangent of theta. So as soon as I see a tangent of theta to theta, maybe I should convert that into the identity, which is tangent of 2 theta is 2 tangent theta, right? 2 tangent theta over 1 minus tangent squared of theta. You will have that formula provided. I don't expect you to have it memorized. Minus tangent of theta. Okay. So I see a 1 and a tangent squared theta. My immediate thought is to try and look for one of my my trig identities. So I'm going to look back through them. Highlight them. Do I have a 1 minus tangent squared theta? Nope. 1 plus. So it's not going to work out. Unfortunate. So back to the drawing board. Okay. Well, I could put it all over one roof. At the end of the day, I do need to get this to be one singular term, tangent theta times sine 2 theta, a secant 2 theta. Pro tip, if you ever have one of the not double angles that we like cotangent 2 theta or secant of 2 theta or cosecant of 2 theta, it might behoove us to write it in terms of sine real quick on the side. And so that's what I'm going to do real quick. Secant of 2 theta is equal to 1 over cosine of 2 theta. Okay. And cosine of 2 theta could be a myriad of things. It could be 1 over cosine squared theta minus sine squared theta. Or it could be 1 minus 2 sine squared theta. Or it could be 2 cosine squared theta minus 1. I'm just going to have those for reference. I don't expect to have them memorized. You're going to have a sheet that you can use. I'll make sure that the other, yes, go ahead.
You're just putting in there so that you start like trying to see how, as you're working down, it might match one of those, how to get to one of those.
Exactly right. So I'm looking at it and I want to see if I can get the denominator to look like 1 over cosine squared minus sine squared, or 1 over 1 minus sine squared theta, or 2 cosine squared theta minus 1. I'm like, that's just me looking for something to keep in mind. I don't know if it's going to work, but it definitely wouldn't hurt. Wishing a person a good day, right? Doesn't hurt. Could help their day. So I'm going to go ahead and do that. So I'm going to multiply this thing by, let's see if that works. I don't know if it will, but 1 minus tangent squared theta over 1 minus tangent squared theta. And that will give me now 2 tangent theta minus tangent theta plus tangent squared, tangent cubed theta, all over 1 minus tangent squared of theta. Keep in mind, by the way, I'm going in blind. I don't know if this is the right choice. So we're seeing if it will be. It might be, it might not be. I have a feeling that it's not the right call, but never know. Brian, you have a question?
You multiply tan theta by 1 minus tan squared theta to get them the same
Denominator.
denominator, so you could combine them, right?
So, actually, this is going to work out. This is going to work out. So let's simplify that with a little bit of algebra. So we get tangent of theta minus, plus tangent cubed theta, all divided by 1 minus tangent squared theta. Okay. Keeping in mind what we want to get to, one thing I do notice is that the right-hand side has a tangent theta. So I could, hypothetically, I could factor out a tangent theta from this numerator. I could do that. Let's see if it works. Tangent of theta times 1 plus tangent squared theta, all divided by 1 minus tangent squared theta. Okay. I got the tangent theta done. So somehow I need to show that this is secant of 2 theta. Does that make sense? There might be another way. There are probably faster ways. There probably are. But I'm looking at it, and I do know that 1 plus tangent squared theta, that's a trig identity. And that could help. Could. Wouldn't you? We want to try it? Okay. This is a Pythagorean identity. This is secant squared theta. So this is now equal to tangent theta. And I'm going to bring that completely out front. Times secant squared theta over 1 minus tangent squared theta. Okay. There's probably a faster way, by the way, just so we're clear. There's probably a million ways we could have done this faster, and you can always go back to the drawing board. It doesn't hurt. So I'm at kind of a loss, at least right now. I'm at a little bit of a loss because there's not really much I can, I could convert the secant back into tangents. I could convert the tangent squared into a secant squared situation to maybe get me somewhere, but I don't think that's going to work. So if all else fails, what should you do? Sines and cosines. If nothing's working, let's convert it to sines and cosines. I'm going to keep the tangent theta in terms of sines and cosines because that needs to be a part of it. That's this. I've gotten that done. I just need to convert this to a secant 2 theta. So I'm hoping I can convert it into sines and cosines. Secant is every s gets a c, so this is 1 over cosine squared theta over 1 minus sine squared theta over cosine squared theta. Okay, and then what should I do? Common denominator in the common denominator in the big denominator. So I'll multiply this by cosine squared theta over cosine squared theta. And so I'm starting to see something form. Tangent of theta. And I got 1 over cosine squared theta over, big bar, cosine squared theta minus sine squared theta, all divided by cosine squared theta. Ha-ha! So now we can flip and multiply, and the cosine squareds will cancel. And so this will be equal to tangent of theta times 1 over cosine squared theta minus sine squared theta. Though you could skip multiple steps and do them all at the same time, because this is cosine of 2 theta. That's the reason why I did this up in the first place, is to make sure I could get it related back to cosines. It might have helped it, it might not, but in this case it did. There was a much faster way to do this, by the way. I just did it the long way.
Not really. Your solution guide had just many steps. That's why I wanted to do this one.
Okay. I guess it's been a while. So I blacked out on that one. Yeah. But it's a good one. It's a fun one. Yes, space.
Yes. Maybe it's a little too late to ask this, so for the top right there, the top right here, I thought like you only use the double angle identity for on the right side for tan, when there's a tan 2x, and like, yeah, I think we use the double angle identity right here.
From here to here?
Yeah.
For here?
That, yeah,
From here to here. Yes.
that. So, yeah, it looks like you use double angle identity, right? And I thought that only works like if you have the 2x.
Well, so theta, like the variable doesn't matter. So 2x. So honestly, that brings up a good point. The identities are always true, regardless of what x is. So I can substitute whatever I want. In fact, so if I had tangent of 2 times y minus 1 over 7, this could be converted to tangent, 2 tangent of y minus 1 over 7 over 1 minus tangent squared of y minus 1 over 7. So we can think of y minus 1 over 7 as our theta or our x, because I can always just let x equal y minus 1 over 7. And then this, now this becomes x.
Yeah, I know there's an x there, but like I'm saying, like there is like a 2 on the right. That's like, yeah. Or tan, it's just tan. It's not like tan 2. It's not like tan 2.
Right here.
I'm saying like for
Here.
the double A. I'm sorry.
It's all right. It's all right. I'm just having a hard time understanding what you're talking about. Go ahead. Circulate.
I can point it out. Yeah, so right here.
Right here.
Right here. So this part right here, when yes, it says like I thought like you could only do the double angle identity if there's like a 2. There are 2 times it's like double angle, but there's only 1. There's only tan. It's just like regular.
Okay. I see. So that tangent is already there. It's a separate tangent. Oh, sorry. Got tripped out for a second. There is a tangent there, but it's a separate tangent. This tangent 2 theta becomes this.
Okay, I see.
Yeah, the other tangent is just sticking around for the ride.
So you kind of combine them, so it becomes tan 2x, I think, tan 2 theta.
Yeah.
I see that.
All right. And since that's 1 over cosine of 2 theta, that's equal to secant theta. So this is, or secant 2 theta. So this is equal to, at the end of the day, tangent theta, secant 2 theta. And we've proved it. Jake, and then do you have a question? Okay.
So I think the one that you need to do this one is, it's just extremely time consuming. I mean, even with a little bit of discussion, it took us 15 minutes to do this one. We have an 8-minute, time limit on the test. This one took me a long time to solve. Are they gonna be a little easier on the test or not?
Yes.
Okay.
This is like, so my mentality whenever I do exam reviews is that like, it's supposed to be harder than the exam. Like, if you can do the exam review, you should be well prepared for the exam. That's my mentality. So this is a very, very long one, but notice how many things we had to learn. We had to practice. We had to work with our algebra. We had to work with our trigonometric identities. We had to work with our factoring and things like that. So this is, yeah, this one, if it was on there, this would be like, I would only put 1 trig identity. So that's the thing. So like, it would be like, if this is the one, I'm also toying around with the idea of giving a hint for like a 1 point deduction. So like if you want a hint on how to get started, I might be able to, like, I'll give you a hint on where to go. So
Like, go.
the way I've done it in the past with classes is I put on the note of the problem that says a hint can be provided for a 1 or a 2 or a 3 point deduction, depending on the how big the problem is, and not to exceed 0. So not to reduce below 0. So I'm not going to penalize you for asking for a hint and then getting it. Like, so if you don't figure it out with the hint and you get a 0, I'm not going to give you a -1 on that problem. So it's a situation where if you get it right, you would normally get a 6 out of 6, but now you're getting a 5 out of 6 because it's a 1 point deduction. But if that helps you figure it out, then 5 is better than 0, right? So I think I'll probably do that. I'll probably be willing to give a little bit of a hint for like a minor deduction, because like especially with these ones, if it can be a situation where if you don't see the trick, or if you don't see the like look at it in the right lens, it will make it harder.
Or if you go down the wrong path too many times.
Yes, that's true. All right. Any other ones?
Well,
12B. Yes, 12B. Well, B. All right, solving that equation. So just like any other equation, isolate the cosine. So cosine of x will equal 2/3. And so that's not a nice number. That's not one of our nice numbers. That's not square root 3/2. That's not square root 2/2. That's not 1. That's not 0. So we have to use our inverse trig. So x equals cosine inverse of 2/3. And my calculator is in radians already. Good. 2 divided by 3 is 0.841. Approximately 0.84 radians. And so, as a reminder, that's going to be in quadrant 1, because theta over 2 is roughly 1.5-ish. So that's in the first quadrant. So looking at a number line, or not a number line, sorry, I'm thinking about 126. That's going to be approximately right there. So this is angle X. And that is 0.84 radians. 84. But because that is right where it needs to be, that also makes the reference angle. This is also equal to X sub reference. Is that okay so far? So because that's in the first quadrant, the angle itself and the reference angle end up being the same thing. It's the only quadrant where that's nice and neat. But because cosine is positive in the first and the fourth quadrant, we have a second solution down here, where it actually is the same value here. This is X sub reference, which is 0.84. So how do I find X sub 2? Take a second. Make sure you digest it, because this is something you'll have to do on the exam. That's you might need to do on the exam. I can neither confirm nor deny the existence of such a thing. But if it were on there, we would need to be able to do this. How do I find X sub 2? Marcus. Does everyone else agree? Yep. Because this is a full 2 pi. And if we take off the reference angle, we just get the green. So X sub 2 will equal 2 pi minus X sub reference, which is 0.84. So that's going to equal, whoa, don't go there. Equals 2 pi minus 0.84. Gives me 5.44. And that is also a number between 0 and 2 pi. And so those are our solutions.
how do you determine the rating of both quadrants? Like, for example, like on the one, you said that 2 pi was 6.28. How do you determine the rating?
So pi is approximately 3.14, right? Pi is an irrational number. It goes 3.14159.6 something. I have like 5 decimals memorized, but so if I want to know what 2 pi is, I'll just take 3.1, like approximately what 2 pi is, I'll just take 3.14-ish and multiply by 2. And if I want to know what pi over 2 is, I'll take 3.14 and divide that by 2. So on a number like this might be something, big thing. Sharice asked me this before class started, and I want to remind us. If there are trigonometric equations, I mean, there are going to be trigonometric equations. Let's be real. There's going to be at least one. I'll provide a filled out unit circle for you. So you can use that for reference. You don't have to have them memorized. So don't be too worried about that. But you can do with that reference angle. This is 0 or pi or 2 pi, which is 6.28. This is pi over 2, which is approximately, if you do that in your calculator and you look at the decimal version, you get 1.57. So I'm taking pi over 2 and I'm dividing, like I'm taking 3.14 and I'm dividing it by 2. Your calculator, it'll give you, if you have my calculator, it'll give you the exact form. So if you do pi divided by 2, it'll write pi over 2. But if you press the S to D button, it'll give you the approximation. And this is 3.14. And then 3 pi over 2, which is going to be 3 pi divided by 2, is 4.71. So if your number is between 0 and 1.57, it's quadrant 1. If it's between 1.57 and 3.14, it's in quadrant 2. If it's between 3.14 and 4.71, it's quadrant 3. And 4.71 to 6.28, it's quadrant 4. All right, Brian.
Would it have a word with pi plus the reference angle?
Pi plus the reference angle?
Pi plus 20 to get to the.
Excellent question. Sadly, that would put us over here because this is a full pi. So it would put us in the wrong quadrant.
I was trying to visualize.
Yes.
I didn't know where to learn.
All right. That'll do it for today. If you guys have any questions, feel free to email me. This week is the week of the young child, by the way. It's a celebration of young children. So if you have a young child in your life, make sure you say hi to them. Show kids a special affection, like, say, what are you interested in? Listen to them talk about Paw Patrol or Roblox, so whatever it may be. It's important for them to know that we care. Okay, guys, have a great rest of your day. Good luck on the studying, and I'll see you on Wednesday for the exam.